It says it decouples the implementation from the abstraction. Abstraction and implementation can be extended independently, and changes to the concrete abstraction classes have no effect on the implementation. These principles will get more clearer when we are going to see this scenario. So let's see, if we have to design a remote client for a set of music players. So this remote client can be considered as a remote control device. So we have to design that for a set of music players. Addition of new features in remote client should not affect or should always be compatible with the music players. Okay. So now if you see here, remote client or a remote control device is a separate application. Music player is a separate application. Okay. And overall they need to talk to each other for the overall application to work, but still these two are separate entities, and whenever I add new feature to one of the entity, it should be independent. So which means there shouldn't be a tight coupling between these two entities. Okay, so now see this principle again. Decouples the implementation from the abstraction. So here the implementation, it is talking about the music player application, and the abstraction is my remote control application. Okay, so it decouples these two application. So point number 2, abstraction and implementation can be extended independently, which means that I can extend my remote control application, add more features to it without affecting the music player application. Okay, so they both can be extended independently. And similarly, the third point says the same thing. Changes to the concrete abstraction classes have no effect on the implementation. Okay, so now I have two set of entities, both can be extended independently without affecting each other, but still for the overall application to work, they need to talk to each other. So there comes the role of a bridge, which enables the one entity talk to the other entity. Okay, so let's look at some code for this. So I talked about remote client. So this is my abstract class for the remote client, which has abstract methods such as turn on, turn off, play, and set song. Okay, and this is my music system abstract class, which also has abstract methods such as turn on, turn off, and play song. But if you see, when I'm going to call the turn on method on my remote client via its concrete class, then an actual remote control will have no logic to turn on the music system. That logic will lie in the music system, in the concrete class of music system. Okay, so remote control just triggers the action. So my implementation entity is music system. Okay, and my abstraction entity is remote client. And as I said, how it's going to talk to the music system is via bridge. So this is the bridge, a data member of type music system, and if you see, remote client is having has a relationship with the music system. Okay, so if I show you a concrete concrete class for this remote client, so you see in its constructor I am passing music system to it, which I am mapping it. Okay, so this music system reference is a bridge. Okay, so let's see the overridden methods of concrete remote client. Turn on. So what it is doing is it is in turn calling the turn on method of music system. Okay, because music system is having the logic to turn on the music player or the music system. Similarly for turn off, similarly for play. So it's going to call the music system dot play song. Okay, and I have one more method, set song, which is just going to set the current song number to whatever song number I pass. So coming on to the point one of the principles of this design pattern, bridge design pattern, I have two set of entities. Okay, and these entities are independent of each other. They are not tightly coupled. Okay, and I am having a bridge through which one entity talks to the other. Okay, so let's run this. Let me also show one of the concrete class of music system. So music system series 1. So if you see, it's override and turn on method. Here I'm going to write the actual logic to turn on the music system. Similarly for turn off and for play song. Okay, so now let's quickly run this and see. So I'm creating object of music system. I'm creating object of remote client, passing this music system to the constructor of concrete remote client, and this music system is going to act as a bridge. Okay, and then I am calling these methods turn on, set song, play, and turn off. So if I run this, so you see it is printing this music system series 1 turning on when I call this turn on. Where this is coming from is the implementation part, music system series 1 turning on. Okay, so this is coming from the implementation entity, whereas the call is made on the abstraction entity. And how this abstraction entity is able to talk to the implementation entities via this bridge. Okay, similarly for when after setting song as 5, when I say remote client dot play, then here it's gonna call this play song method on this bridge, and it's going to pass on the current song number, and my implementation entity is going to act. And for now it just printed music system series 1 playing song 5, but in actual application it's going to execute the logic to play the song number 5. Okay, similarly turn off. Okay, so the point number 2 and 3, it says that whenever these two entities, implementation and abstraction, can be extended independently, and I should be able to add feature to either of them without affecting the other entity, which means that, as I said, like if developers who are working on abstraction entity, if they want to add more feature to it, they should not be in a shape that they have to ask the developers of music system to change its class design or do some code change. Okay, so let's see how it's gonna work. So I have this remote client, and as a developer, I want to add two more features to it: next song and previous song. So let me put it here. So apart from setting the song number and then playing that song, I want to have few more buttons on my remote control for next song and previous song. Okay, so I did this, and then in the concrete class I'm going to go here and override it like this. Fine. Next song, what I'm doing here, just incrementing the current song number, setting it so that whatever is the next or the incremented song number gets mapped to the current song. Fine. And similarly for this thing, if I do this previous song, I am decrementing the current song number and setting the decremented song number to the current song. Okay, so I have added these features to my abstraction entity. I have changed the code, I have extended it further, but I need not do any changes in the implementation entity. Let it be as it is. So now if I'm going to go here and say I call this next song, then I will play that song, and then I call previous song, I'm going to play that song also, so like this. And when I'm going to run this, so it says turning on, then it set the song number 5 and then played it, so it printed music system series playing song 5. Then I changed to next song, which changed the song number to 6. I played it, it says playing song 6. I went to previous song, again to song number 5 and played it, playing song 5 and turning off. So you see, I have two entities as a overall application. They both are important, they need to talk to each other, but still I am able to extend one entity without affecting the other entity, and my both of these entities talk to each other using a bridge. Okay, so this is a very simple use case of bridge design pattern. If you see more complex use case, then it is maybe useful in say in some graphics and windowing systems that needs to run over multiple platforms. Okay, so the platforms are multiple, it's a separate entity. My graphics and windowing system is a separate entity. Okay, it needs to talk to each other via bridge, and I should be able to extend my graphic system independently, and same goes for the platform. Okay, fine. Okay, thanks a lot, friends.